All right, so here's what I want to show you. It's how you can take the INE version 5 CCIE lab book, and you'll have 10 routers. And now I'm using the backplane connection with this Linux box right here. But how can we drop the files on there? And how can I remove those files automatically, reduce error, and just not make it such a redundant, repetitive task every time you want to do a different lab? So let me show you what that looks like. If you open up the Linux box, let's see, accessories, VS Code. Let's see how big I can make this. Whoa. Okay, so show brief. What this is going to do, oh, actually, Netmiko, let's do show config. I'm going to run this script. Let's see. So all this is doing is it's just going through each of the 10 routers, and what it's going to do is just pull a show IP interface brief and also do a show IP protocols just to verify I don't have anything on the interfaces that I don't want, and I also don't have any protocols running such as OSPF, BGP, or EIGRP. Any of those routing protocols that I don't want. So as you can see, if I scroll down through here, 11 is my first one. I only have 12 and gigabit Ethernet 4. That's my management interface that I have connected to the Linux box. But this is just to verify that I don't have anything on those. Okay. 15, 16, 17, 18, 19. Again, 19 is 9 for me, and then 20 is 10. I could have IP'd it a little different, and I probably will when I recreate this. But just to verify that I don't have anything running on there. Let's see. Get him rid of. So, for example, if I log into router 3, Cisco, show IP interface brief, show run. There's nothing on there. The only thing that's on there is Gigabit Ethernet 4 is just a reminder, hey, don't touch this interface. I'm using it for management. Okay, so now how do I throw a config on there? Now what kind of config am I trying to throw on there? Well, let me show you. I go to ine.com to log in. Okay, so if you go up here, go to workbooks, let's go to CCIE version 5 lab book. Okay, so I'll give you an example. I want to work on some BGP stuff. Whoa. Okay, so let's scroll down to BGP, and as you see, there's a bunch of labs in here. Let's do establishing iBGP peering. Pretty easy. Now what it'll do, it'll give you this little blip right here. You must load the initial configuration files from this section named initial BGP. Okay, so if you clicked on this folder, oh well, resources, topology labs. Oh, all right, so there's this big zip file. Now let's see what this looks like. Let's extract it. Now this is a big folder. So again, this is going to be the initial configs for hundreds of labs. And it's going to say router 1, use this initial config. Router 2, use this initial config. And the whole point of this is I don't want to log into every router, clear the config on there, and then load the initial config for this particular lab. In a perfect world, I would want to press a button and have that done for me. BGP, let's scroll down to initial BGP. And again, so you got router 2, that's the config they want you to drop on there. Or router 4, that's the config they want you to drop on there. And the whole point of this is it's gonna you basically will treat the lab as if it looks like this. Okay? So you don't see what you would see on Eve. Eve is just how it's actually set up. Now you treat it like this. Okay? So let me show you what that would look like if I went and dropped that config on there. Back to here. Okay. Back to VS Code, Netmiko. Clear that off. And I want to run initial BGP. So directory to use, initial BGP. Initial BGP. Press play. And with a simple press play, all it's going to do is go in there and load the config onto every router. This will take a minute. So as you can see, I got, so that's the management interface, 11. So that's going to be router 1. That's router 2. And again, this does take a minute, but much easier to do this and 100% accuracy to make sure that you have the exact config you want on there, then go in there and manually doing it. So you can see if I look in here, the config's been dropped on there. It's neighboring up, creating new adjacencies. Like the lab is being built with the press of a play button, which is exactly what we're hoping for here. If I go back here, I'm done with that. I'm done with that. And I can do show config again, just to confirm that everything has changed and now there's a config loaded on every one of them. And again, what this is showing is if I go to the top, for example, router 1, again, that's 11 for me. Those are the interfaces I have on there. Then I do a show IP protocols. I'm running EHRP 100. This guy's running EHRP 100. Some of these routers should be running BGP as well. Or, hey, maybe that's part of the lab. Okay, so that's how you would do it. And to verify, let's see, show IP ERP neighbors. Yeah, you got neighbors, pretty easy stuff. Now, how do you strip the config off there? Let's say you wanted to start a different lab. Well, that's what we're going to leverage Ansible for. We'll go back here, start over. So CD documents, Ansible playbooks. Let's see what we got in there. I have a playbook called remove config. We'll do Ansible playbook, remove config. So the play is remove config. I do find that if I let it gather facts, it logs into the routers. And I don't know, in a sense, it kind of wakes them up. Um, I don't know. For some reason, I find that increases the accuracy in which it'll perform the task without messing up. So the task here was delete the IP protocols. It went through all the routers and gave an OK, deleted those. So that started at 18 seconds. This one starts at 26 seconds. So that took 6 or 8 seconds roughly. Now the remove interfaces command, that does take a little longer. That's probably a 3 minute task. Now, why is that a 3 minute task? Because this is the YAML file. So what this is doing is going to all my routers. I have a task to delete the IP protocols. Thus far, it's only looking for these IP protocols. EIGRP 100, BGP 100, BGP 3, BGP 54. Pretty easy there. And then the next task is remove the interfaces. But there's a lot of interfaces on here. So what it's doing is it's looping through every router. It's looping through every one of these interfaces. And just to make sure, like, hey, if you have Gigabit Ethernet 1.79, we're going to make that absent. So it's going to delete it off there. And it's going to loop through every one of these. And now these aren't just random interfaces that I put on there. As I've done labs, these are the interfaces that get populated on there when I load them on there from various labs. There's there's probably a different way to do this, and I know there's a different way to do this. There's probably 10 different ways you could do this. But this is the way I found, and I don't mind spending 3 to 4 minutes to wipe a config off. If anything, I could go take a break for 3 or 4 minutes while I come back. So as you can see, it's coming through here, making sure these interfaces are not on the router. And then the last thing it'll do, save running to startup when modified. So what it'll do, once it removes these interfaces and it removes these IP protocols from it, if it noticed there was a change or the config has been modified, it's automatically going to save it at the end. And again, this takes 3 or 4 minutes. Not a big deal. So that task ended at 4:30. And it started at 26. So again, that's about a 4-minute task. Again, the total task or total time for the playbook to run, 4 minutes, 43 seconds. Now to verify that this did what it said it was going to do, I'll go back to R3, show IP interface brief. All these interfaces have been deleted. Show run. There's nothing on here. I don't have any IP protocols. I don't have anything. And that's how you can start a lab. And that example, what I started was the initial IBGP peering relationship. But you could load the configs on there with Netmiko and then leverage Ansible to remove the configs. But now, if you want to know how to do this, well, that's the goal. I'm basically going to start this from the very beginning and walk through every step of it. Hope you join along.